Hello Babas. So this is the video I said I'm gonna make. It's stoichiometry. So previously we looked at mole formulas. Then I did 10 calculations of easy mole sums. Now stoichiometry itself is where we bring everything together into a bigger question. Say 15, 16 mark question on its own. And honestly, I don't really think it's difficult. I just think that the English itself, like I said in class as well, the English itself, if we can get it from English to the numbers, then we can calculate it. We must just take the time to see what we have, what we want, and then we can calculate it using the formulas and then the ratio of stoichiometry. So when I'm dealing with stoichiometry, there's always 5 steps that I keep in mind. So the steps start with step 1. Always look at, this is easier. That's my 5 basic steps. So step 1 is check if the equation that they're giving us, the chemical equation, if it's already balanced. So most of the time it is already balanced, but we do need to check, and we know how to balance. We did it in grade 9 and grade 10 as well. Easiest way for me to check just fast is if there's a coefficient in front of one of the substances, doesn't matter product or reactant, then it's balanced. Or they will tell you it's balanced. But step 1, make sure the chemical equation is balanced. Step 2, identify what's given and then what's asked. They will always provide information for us to be able to calculate a mole. Either it's mass or volume or number of particles, they will give us information to be able to calculate a mole. And once we get a mole, we can use the ratio, step 4, use the ratio to calculate another mole. Get a mole, calculate another mole. As easy as that. And once we have another mole, we can finish up the sum. So if they ask us substance 1 and we calculated the mole of substance 1, we use the ratio, and then we can get any other of the substances moles by using that ratio. It can be 2 products or 2 reactants, doesn't matter if it's a reactant or a product. As long as we get 1 mole, we can calculate the other mole using ratio. Today I'm going to go through question 5 of the Northern Cape 2026 June exam paper, the one they already wrote. I'm going to go step by step, question by question, and just do it with you guys. I hope it's insightful. I hope that the world is going open. Alright Babas, as I said, I'm going to go through question 5 of the Northern Cape paper they recently wrote, and it reads the following. Study the balanced, that was step 1, chemical equation of the reaction between sodium carbonate and hydrochloric acid, HCl, and answer the questions that follow. Alright, so step 1, they already told us it has been balanced. Then step 2, let's check what we can get. We need to see what's the given and then as well as what has been asked. Right, first of all, 5.1. Identify the type of reaction above. Choose from gas forming or redox. It's going to be gas forming. It's forming a gas. Then 5.2, that's the question I want to focus on. In the reaction, 10.6 grams of sodium carbonate reacts completely with excess hydrochloric acid. So in the end, they did give us 10.6 grams. So for this, let's make this green. For green, we've got small m, the mass, which is 10.6 grams. Alright, then we're gonna continue. Calculate the molar mass of sodium carbonate. So molar mass, they want us to calculate the capital M, molar mass of sodium carbonate. Now, if they do, no, let's not say if, they will. It must be a balanced chemical equation. So, when they give you the symbols of your elements and they ask molar mass, it's not a guessing game. It is where we're gonna go to our periodic table and we just gonna calculate molar mass. So to calculate molar mass, it's 5.2.1. So we want molar mass of sodium carbonate. First things first is, let's check if we can find sodium. So sodium is here. We look at the atomic mass, which is 23. So it's going to be 23. There's 2 of them, so it's going to be multiply with 2. That is for sodium. Then we're going to check if we can find carbon. So it's going to be plus then carbon. There it is. The relative atomic mass is 12. So we're going to write it down. 12. There's only one of them, so it stays exactly as it is there. And then the last one, oxygen. So it's plus then the oxygen. Oxygen, we're going to check. It is there. It is 16. So we're going to write our 16. There is 3 oxygens, so it's multiply with 3. There we go. Alright, babas. So we're gonna smash it into our calculator now. So it's gonna be bracket 23 multiply 2, close my bracket, plus the 12 of carbon, plus, then I have a bracket there, 16 multiply with 3. You can see I type it in exactly as I wrote it down. I'm not gonna be fancy. I'm just gonna get it. So it gives me the answer of 106. So my molar mass is gonna equal then to 106 grams per mole, and per means negative, and then your 1. Alright, so after this question we have 2 things. We have the molar mass now for sodium carbonate, and we have the mass of sodium carbonate. Let's go back to the question then. So we're done with that. Perfect. Question 5.2.2. Initial number of moles of sodium carbonate. So they're asking initial number of moles. They want us to calculate the moles. Alright, so mole, that is 5.2.2. The mole is what they want. So I'm going to check what is given and what do I have and what do I need to calculate. The mass they gave us in the question was 10.6 grams. And now the molar mass that we have calculated is 106 grams per mole negative 1. Alright, from there we go to our formulas. Now if you remember the formulas, we go to our formulas. What do we have? We have mass, we have molar mass, we want mole. We have mass, we have molar mass, we want mole. So from the formula sheet, we're going to write down the formula first. Always write down your formula first. So it's mole equals mass over molar mass. And then from there, we're gonna substitute. So mole is what they ask, and it's gonna be 10,6 over the molar mass that we've calculated, 106. We're gonna come to our calculator, we're gonna smash it in there, so it's gonna be 10,6 divided with 106, and my mole is gonna be 0,1 mole without the E. Oh wait, so far so good. Let's go. Then my next question, 5.2.3. Calculate the mass. Let's get a different color for this one. Calculate the mass of carbon dioxide produced during this reaction. All right, so do we have any information about carbon dioxide except that it's a product? Any other information? We do not have any other information. That means we need to go to the next step, which is ratio. So to do the ratio, we need 1 mole. Do we have 1 mole? Yes, we have the mole of sodium carbonate. All right, so for 5.2.3, they ask us now to calculate the mass of carbon dioxide. All right, so let's say it's for carbon dioxide, then they're asking mass. All right, with that, we do have molar mass. When they give us the name, we can go calculate our molar mass. So carbon, as we saw previously, was 12, plus then my oxygen was 16, and there's 2 of them, so it's multiply with 2. I'm gonna smash that into my calculator, so it's gonna be 12 plus 16 multiply 2, close my bracket. It gives me an answer of 44. So I have 44. And then obviously we are dealing with moles, and we don't have moles yet. All right, that is where the ratio comes in of stoichiometry. All right, so to calculate the ratio, we need to look at our balanced chemical equation. So to look at our balanced chemical equation, we have the mole of sodium carbonate at this moment. We want the mole of carbon dioxide. All right, so with the ratio, we use what we call the coefficients. It is the numbers in front there, so 2 for HCl, all right, but the numbers in front. There's no numbers there and there's no number there, which means both of them is a 1 and a 1. All right, so that means if I write down my ratio for sodium carbonate versus carbon dioxide, all right, my first line is going to be my ratio. So my coefficient is 1 for sodium carbonate and 1 for carbon dioxide. So it's going to be 1 and 1. Let me do a little line there. So it's 1 and 1. All right. I also then have the mole sodium carbonate. I'm so sorry. Anyway, so that mole, we calculated it there. So we're going to fill it in there, 0,1. And then carbon dioxide, that mole is the one that has been asked. Okay, let's go over this quickly. So I write down the two substances I'm gonna have in my ratio. So the first one I write down is gonna be sodium carbonate, right? Then I write down their coefficients from my balanced equation. Then I add the mole of the one that I have, and I add a x at the one that I want. So I want the mole. Let's take another color. So I want the mole of carbon dioxide. All right, so we're gonna cross multiply this there and that one and that one and that one. So it's gonna be 1x equals 2, doesn't matter the order there, 1 multiply, forms a little multiply there to remember it, multiply 0, 1. All right, obviously when it's 1 to 1 we can immediately see that it's 0, 1, and that is going to be 0, 1, but I'm just showing you the maths behind it. So it's going to be, obviously we want to get rid of this 1, so we have to divide because it's a multiply, and we have to divide it that side, so it's going to give us our x alone. And then I'm going to smash that into my calculator, so it's going to be 1, it's there, it's going to be 1 multiply 0, 1 over that 1, and that is going to equal to 0, 1, as we knew it would be from the start, because the ratio is 1 to 1. But hopefully you understand the maths behind it now. All right, so we can go from here now and we can add it in there, 0, 1. All right, so if we go back to our question 5.2.3, the mass of carbon dioxide produced during this reaction. All right, so we want mass, baby M. We want baby M. So we've got baby M, molar mass and mole. We go to our formula sheet, even though we already know we want mass, we have molar mass, and we have mole. So we're going to use exactly that same formula as previously. So it's going to be mole equals mass over molar mass. Remember, you have to write your formula as it is on the formula sheet. I advise that you first substitute. So we're first going to substitute mole. We've got it as 0, 1 equals mass is what we want, what we really want. And then our molar mass, we calculated it there as 44. All right, and then we do some maths here. So basically I want mass alone, the baby M. So I need to get rid of this. It's divide by 44. How can I get rid of it? By multiplying with 44. And what you do on the one side, you're gonna have to do on the other side as well. So that's gonna give me 0, 1 multiply the 44 equals to my mass. Da, 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 da. And therefore my mass is gonna be, you guess it, we're gonna smash it into a calculator first. 0, 1 multiply 44 equals 4, 4. So my mass is gonna be 4, 4 and grams. Beautiful. Our first stoichiometry ratio done. All right, babas. Let's rush through the next one. I'm gonna turn over a page. All right, babas. So I turned to a new page. I started to read the question without recording it. So here we go. The last one. 5.2.4. Calculate the mass of sodium chloride. So basically they are asking the mass of sodium chloride, and they ask the mass of
that produced if 4,87 cubic decimeters. Cubic decimeters is the unit for volume, all right, of carbon dioxide. So they are speaking about carbon dioxide again. So let's use another color. It's going to be sodium chloride versus carbon dioxide. Anyway, they gave us the volume of 4,87 cubic decimeters of carbon dioxide was, okay, let's start over. Calculate the mass of sodium chloride produced if 4,87 cubic decimeters of carbon dioxide was produced at STP. STP, as you can see, I already wrote it there, means we can use molar volume. So if you can remember from this video, molar volume is when we use molar volume is when they say STP, and then we can use a constant number that you get on the formula sheet for molar volume. And there's also a little formula we can use. Mole equals volume over molar volume. So, because they say STP, it means that we can use molar volume, the constant 22,4 that we can get from our formula sheet. Alright, babas, then let's go to this side. Sodium chloride. With sodium chloride, because they gave us the name, they also gave us molar mass. Remember it. When they give us the name, they give us molar mass. We just need to go fetch it from the periodic table. Alright, Baba, so let's jump into this little question. I cannot use the mole that I calculated previously for carbon dioxide because now we're dealing with a specific volume of carbon dioxide. So I need to redo the whole mole sum over, alright? Because we're dealing with a specific volume now. So I have volume, I have molar volume. I already showed you the formula from the formula sheet. It's mole volume over molar volume. Then we're going to substitute. So mole, my volume, is 4,87 over 22,4. Guess what I'm going to do now? I'm going to smash that into a calculator. So it's going to be 4,87 over 22,4, and that equals to 0,2174 blah 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 blah. Yes, the rule I want you guys to follow is we keep as many decimals as what we can, but let's cut it off at 4 decimals because this is not the final answer. All right, so we want to keep the sum as accurate as what we can. So it's going to give us 0,2174 mole. Okay, almost I wrote that E. So basically we have volume, molar volume, and now we have the mole of carbon dioxide. So remember the ratio now. When we have a mole of one substance, we can use a ratio to get the mole of the other substance. Okay, so it's going to be a little bit confusing, but let's jump into it. I mean, the order I'm using the paper on, but let's jump into it. So I have sodium chloride versus carbon dioxide. First line is where we write our coefficients. All right, so coefficients. So this one here is a 2 for sodium chloride, and then for carbon dioxide it's going to be a 1 as we saw previously. Then from there the next line is going to be where we write our moles. So carbon dioxide, we calculated the mole as being 0.2174, and we want this mole, so it's gonna be X. Then we're gonna cross multiply, so it's gonna be 1 multiply X, so it's gonna be 1X equals then 2 multiply with the mole of carbon dioxide, so it's going to be 2 multiply the mole 0.2174, and then I'm going to smash that into my calculator, so it's going to be an X. I'm not going to divide with the 1 again, so it's going to be 2 multiply 0.2174 equals, and the reason why I'm not dealing with the 1 again, because we all know multiplying with 1 or dividing with 1 keeps the answer the same. 3, 4, 8, and that is now my mole for sodium chloride. So 0.4348. So let's remember the question. They ask us the mass. Alright, so they ask us the mass. What we need here now is molar mass. So sodium from the periodic table, let's do it one more time. Sodium is 23. There's only one of them. Plus then chlorine is 35,5. 35,5. And let's just change color before it gets too confusing. I'm going to smash that into a calculator. 23 plus 35,5 equals, boom, 58,5. 58,5. Alright, babas. So now we have mole, molar mass, and mass. This little formula should already be stuck in your head, but it's gonna look like this. Let's draw a line. Poof. Anyway, I'm gonna calculate the mass of sodium chloride, and you'll see I keep the formula the same as on my formula sheet. Then I'm going to substitute first. So the mole is 0.4348 equals to the mass is what they ask, and the molar mass is then 58,5. Alright, babas, so I want mass alone, so I need to get rid of this 58,5. It is divide, so I'm going to multiply with the 58,5 this side, but what I do on the one side I have to do on the other side. That's going to give us 0.4348 multiply with that 58,5 equals then to the mass. I'm going to smash that into my calculator. 0.4348 multiply 58,5 equals, boom. So therefore my mass is going to be 25,4. I'm going to round off to 2 decimals here, the 5, so it's going to round up to 4, and mass is measured in grams. Ta-ra-ra-ra, ta-ta-ta-ta-ta.